Hello, today we're going to start section 6.1, solving systems of 2D linear equations. The objectives of this section are to solve systems of linear equations by graphing and solve systems of linear equations by substitution. Part 1, solve systems by graphing. A system of equations is a list of equations that you deal with all at once. Our focus here will be on systems of two linear equations. Definition 1. A solution to a system of two variables equations is an ordered pair AB that is a solution to both equations. Determine whether each ordered pair is a solution to the system. 1/2 x plus 2 equals y and y equals 3x minus 3. So let's check -4 is 0. So 1/2 times -4 plus 2. Does that equal 0? 1/2 times -4 is -2 plus 2. That is 0. So this checks out that 0 equals 0. So this is a solution to the first equation, but that does not mean that it is a solution to the system. You have to check it in both. Okay, so for the next one, we get 0 equals 3 times -4 minus 3. 3 times -4 is -12. -12 minus 3 is -15. That does not equal 0. So this is not a solution to the system. So in order to be a solution, it has to be a solution to both equations. Okay, now let's check the point 2, 3. 1/2 times 2 plus 2. Does that equal 3? 1/2 times 2 is 1. 1 plus 2 is 3. That checks out. And check the second equation. So we get 3. Does that equal 3 times 2 minus 3? Well, that's 6 minus 3, which is 3. Which does equal 3. So this one is a solution. Geometrically, we can think of a solution to a system of linear equations as the place where the graphs of both equations or lines intersect. In 2D, there are only 3 possible outcomes. You can get one solution. So that's where the two lines intersect in exactly one spot. You can get no solution. So that means the two lines do not intersect anywhere. Hopefully you remember the term for this, but we call these parallel lines. They'll never intersect. Parallel lines have the same slope. Or you can get infinitely many solutions. That's where you have one line and the other line is right on top of it. So this is because lines don't have an unique point slope equation or unique general equation. Remember, only the slope intercept form is unique. So this is when they have the same slope intercept equation. In other words, same slope and same y intercept. Now, the reason why I didn't write anything for the one solution is because you get the answer to the one solution in contrast. So the reason why they only intersect in one point is because they have different slopes. So you can either look at the graphs like we did here, or you can use different slopes, means one solution, same slope, but not the same equation, no solution, same slope and same equation is infinitely many solutions. Example 3, solve the following systems of equations by graphing. Okay, so if we look at y equals 3x minus 9, that is in slope-intercept form. So that means our slope is 3 and our y-intercept is 0, negative 9. That means I can graph this with just that information, but I need to put units on my graph. Each tick mark will be worth 2 here. So 0, negative 9 will be right here. And then with a slope of 3, I need to go up 3 over 1. Now I'm just going to get a few points there so that I can draw a straight line. That should be good enough. Okay. Now we have negative x plus y equals negative 3. Well, this one is not in slope-intercept form, but it's not that hard to put in slope-intercept form. You add x to both sides, you get y equals x minus 3. So we get a slope of 1 and a y-intercept of 0, negative 3. So we start at 0, negative 3, and then a slope of 1, slope of 1, slope of 1. And there's the equation of our second line. And then our solution is where they intersect. So in this case, our solution is 3, 0. So in order to solve a system by graphing, you do need to draw the lines as straight as possible. If you don't happen to have a straight edge on you, a notebook or the back of your calculator works great. Okay, B. So the first one is already in slope-intercept form, so I know my slope is negative 7/2, and my y-intercept is 0, 9. So again, I need to go by 2's, so let's mark this 10 and 10. So 0, 9 is right there. Then I need to go down 7 over 2. Let me get one more point. There we go, that should be better. The second one's non-slope-intercept form, but what I can do is subtract 2x. So we get negative 2x plus 2. But then I still have a negative on the y, so you have to divide by negative 1. So y is 2x minus 2. So we have a slope of 2 and a y-intercept of negative 2. So 0, negative 2. And then a slope of 2, up 2 over 1, up 2 over 1, and then draw a line. And again, the point where they intersect is our solution. And remember, since each tick mark is 2, that point is 2, 2. And that's how you solve systems of equations by graphing. Example 4. Determine the number of solutions to the following systems and whether they're consistent or inconsistent. Consistent means it has a solution. Inconsistent means it does not have a solution. Okay, So remember, all those definitions, if we don't have the graph from above, we needed to know what the slope was. So in order to find the slope, I'm going to write all the equations in slope-intercept form. So for part A, we have negative 4x minus 10y equals 1. That's not in slope-intercept form. So negative 4x minus 10y equals 1. Add 4x, add 4x. Negative 10y equals 4x plus 1. Divide by negative 10. Divide by negative 10. You get y equals negative 4x over 10 minus 1 over 10. Well, the 4 and the 10 can reduce, so this simplifies to y equals negative 2/5 x minus 1/10. Then if we look at the second equation, it already is negative 2/5 x minus 1/10. So they have the same slope and the same y-intercept. So this one is consistent because it has a solution. And it has infinitely many solutions because they're the same line. And then on the very last page of this notes, we're going to learn a new word, but just for foreshadowing, we also call this a dependent system. Okay. So that's A. B. Negative 7x plus 8y equals 9. Well, that already is non-slope-intercept form, so let's solve that. So add 7x. Divide by 8. So y equals 7/8 x plus 9/8. And then the second equation, 21x over 8 minus 3y equals negative 6, is also not solved. So 21x over 8 minus 3y equals negative 6. The first thing I'm actually going to do here is multiply everything by 8 to get rid of the denominator. So we get 21x minus 24y equals negative 48. Subtract 21x, subtract 21x. Negative 24y equals negative 21x minus 48. Divide by negative 24, divide by negative 24. We get y equals, well, negative 21 over negative 24 is 21 over 24. X. And then 48 over 24 is 2, so plus 2. Now the 21 over 24 can be reduced by 3, so we get y equals 7/8 x plus 2. So now these two equations have the same slope, but different y-intercepts. So that means there's no solution. So this one will be inconsistent. So then there's no solution. And then since it didn't have infinitely many solutions, this one will also be called independent. Again, we'll get those definitions on the last page of the notes. And that is it for part 1 of section 6.1.